Hi, my name is Ryan and I teach computer science. Welcome to our lesson here, fractions greater than, less than. This is a extension of a previous lesson which was a fraction comparison where it was a little bit more simple than what we're going to do here. This one we're going to expand it. So if you're adventurous and want to see how to make this a little bit more complex, you're more than welcome to. We'll be making a system very similar to the last one, except this time we're going to expand the difficulty. We're also going to implement a little bit more of a modular approach on how we break apart the actual function. If you remember the last lesson, or if you didn't do it at all, we had a very, very large script, which worked for us because, you know, this is kind of what we did. But this time we're going to make it much more modular, where we break out the different jobs of the main game engine here, which will be this script right here, which runs underneath the green flag. And when I say game engine, that might be a little bit of an overkill, but we can almost say this is the game manager right here, this particular script. And it's going to call in these other functions to help it out on, you know, making decisions and setting random variables up, as well as doing some calculations on figuring out what's the right and wrong answer. Okay, so let's look at what this program will do. If you did the decimal greater than, less than, this is very similar to it. And also one thing right here, up here on the top left-hand side, you'll see that I have a different title of the file name compared to what I showed you at the beginning when the little intro rolled out there. Don't worry about that. This was my copy. I did a lot of renditions of this, just kind of tweaking it till I got to a point where I was happy with the product, and I just didn't change the file name. So it's no big deal. You'll have access, if you subscribe, to be able to get the student files to work on all this stuff. They'll have everything set up, and all you have to do is just go through and program. So make sure you like and subscribe. I sure would appreciate it. And let's go ahead and check out what this thing does here. And let's go ahead and run this program. It's going to ask for the difficulty that we want. 1 for easy, 2 for medium, and 3 for hard. I'm going to put in, say, 2 for medium. Press enter. Lets us know the round number, and then over here we have our different fractions. Okay, so the difficulty is based upon the how large the range of potential random numbers that will be generated. So that's going to determine the difficulty. And you'll notice that we have some improper fractions here where the numerator is greater than the denominator. So you'll have to do a little bit of calculation. We don't reduce the fractions, but that's part of learning how to figure out fractions. So we'll just go through. You'll be able to answer. You'll notice the colors change when we move our mouse over it. When we click on a option, let's choose B is the correct answer. And if I click on B for the correct answer, you'll hear some people cheering. That's the sound coming off my computer. And then also equals is an option as well. Okay, without further delay, let's go ahead and open up the student file and start programming this game. If you subscribe to this channel, the Discovertron channel, you should have gotten the file called fractions greater than, less than. If you haven't, go ahead and subscribe, and then you can access my downloadable Google Drive. Well, hold on, the Google Drive is not downloadable, but the files inside of there are downloadable. Okay, so let's get started. Did you notice I changed my mouse pointer right here? Okay, I've noticed that with this kind of light gray layout of Scratch, that having a white mouse pointer isn't really ideal, so I switched over to a black one. Hope you like it. I think it's pretty cool. Okay, underneath the events, we're gonna get a green flag tool right here, a block. I always say tools. It's just something in the back of my head. I can't help but call these things tools because they're kind of like tools. But we're gonna get the green flag block right here, which is also known as a hat block. And what we're gonna do is we're gonna build out our management script. It's not per se called a management script, but that's essentially what it does, because it does manage the game, and they'll call on other functions to do all their jobs, as you saw in the previous program. What we want to do is we want to set an XY coordinate. We want these values set so that way we'll always know where CalcuCat goes. I'm sorry, I didn't mention that before. I was so excited to talk about my mouse cursor here, but we're going to start programming with CalcuCat. If you have not ever programmed with Scratch, quickly, this is the stage. The stage is just a backdrop. We're not going to program on the stage, but you can if you want. It's a great place to host centralized scripts. We technically could program all this in the stage, but I'm going to use CalcuCat. Over here are the sprites, and we can also call these objects. And if you look up the root word for sprites, will be amuse for maybe 10, 15 seconds. And then let's see what else we got going on here. Okay, so those are the sprites. If you are new to Scratch, you might want to go watch another video to get you caught up to speed. I'm not going to go through all the ins and outs, but these are the different categories of our blocks. And if you're new to Scratch and you just want to follow along with this video anyways, I'll explain things as we go, and I'm sure you're probably pretty smart and you can kind of piece it together, or you can ask some friends or ask me or something like that. Okay, so we're going to set the XY coordinate to -4 and +68 on the XY axis. Remember, this is the Y axis going up and down, and X axis going left and right. And the center point of the XY axis is right here in the middle. We're going to tell the Calci cat to go to the front, because we want the cat always be in the front. This isn't so much an issue right now because we only have a certain number of sprites, but you could have a scenario where you have 20, 30, 40, 50 different sprites on the screen at one time, so you want to make sure everything's layered properly. Let's see, data. Okay, whenever I make my variables, I just kind of make them as we go, and sometimes I forget to make them all together, and that makes for this video to be a lot of fun as I get confused and frustrated and y'all sit back and laugh at me. The first variable we're going to create is called play again, and what this will do is this will control whether the program keeps running or not. And we're going to go ahead and set this up so the program will initialize. We're going to set it to a capital Y for yes. Okay. We could typed in the whole word Y or the whole word yes, but I'm just going to leave in a capital Y, and you'll see what we'll do with that here in a little bit. Next, we want to create another variable. We're going to call this one round. Click on OK. Let's go ahead and make our other variable. We'll make 2 more. Score. This will keep track of how many points the user gets. And then last but not least, we want the difficulty. Okay, so let's go over here, and I want to set my round number first. I'm going to duplicate these 2 blocks so I can reuse the script and set our score to 0 and set our difficulty to 0 as well. You'll notice over here on the left hand side the little variable windows pop up on the stage area. You can control these by clicking on these check blocks right here, or check boxes, excuse me, and that allows you to control it. We'll clean all this up as we go further along. For right now, I'm just going to leave these right there. And all these graphics I got right here, you probably think I'm some sort of fantastic street artist, but I'm not. I got all these from the Scratch library, so you can do the same thing too if you want. Next, we want to get our broadcast block, and it's underneath events. Broadcast is a powerful tool, and you use broadcast here in Scratch, and it's also used in other languages like C#, which you use with Unity. That's another programming kind of software that I teach, and then it's also found in C++. Okay, so broadcast, this is real skills right here. What it's going to do is it's going to send a message out to the entire program. Sorry, I had to drink some coffee. It's pretty early. So the broadcast is going to send a message out to the entire program, and if anything is set to receive that message, it's going to start executing its code when it receives that message. It's almost kind of like yelling out start, and if somebody's listening for the word start, they're going to start doing something. In our case, we're going to put in a message, and we're going to call this message set difficulty. Okay, click on OK, and now while we're doing this, let's go ahead and build this function out for setting difficulty. So we want to get a when I receives block, and we'll say whenever it receives set difficulty, it'll perform some sort of action. We want a control block that's going to be a repeat until, and we'll put it right inside there. And we want to get some operators. Okay, these operators are going to help us determine what conditions need to be met to help us figure out if we need to keep repeating the code inside here. Let's start off with the OR operator, and let's duplicate it, and we're going to nest it inside of it. You can see where I drag this block right where the right hexagon lights up, and then it nests inside of that. And we want to get in equal, and we're going to go ahead and right click on that and choose duplicate, and duplicate it one more time. So we should have a total of 3 of these, and let's go ahead and put them inside there. So we're going to check 3 different conditions here and see if any 3 of these are true. If this is true, or if this is true, or if this is true, will allow us to stop repeating the code inside of it. We need to get a data block for difficulty, and let's go ahead and set this equal to 1. So the first condition we're going to check to see if difficulty is equal to 1. I'm going to right click on the reporter block for difficulty, choose duplicate, drag it over here to the next one, 2, duplicate, put it right there, and then we'll set that one to 3. Okay, so what we're doing is we're checking to see if difficulty is equal to 1, 2, or 3. In other words, we're going to keep repeating a piece of code in here until difficulty is set to 1, 2, or 3. Over here, right there, we set difficulty to 0. Okay, so when the program runs, difficulty is set to 0, it broadcasts this message, and this code right here is going to wait until this script is done. And this script is going to keep repeating whatever's inside of here until 1, 2, or 3. Okay, how do we change that? Easy. We come over here to get a sensing block, and we're going to choose the one called ask. Ask is more than just asking a question. What it's doing is it's wanting the user to input information. So you can almost say this is a input block where the user types in information with the keyboard, and we want to say, which difficulty would you like? 1 for easy, 2 for medium, 3 for hard. Okay, and the program is going to require that the user enters in one of these 3 answers. Now before we go any further, we have to set their answer to the difficulty variable. We want a set block, put it right there underneath ask. And how do we get the answer from ask into difficulty? Well, you're thinking, well, it should just automatically go in. Well, not so. Remember, computers are not very smart, so we have to tell it what to do with the information from the user to get it put inside this variable. And we can do that by going back to sensing and choosing the answer block. This answer right here, this block, which you can click on this little check mark and it'll pop up over here on the left hand side in the stage area. This is the variable that stores the input from the user, and we can take this and take that input from the user, and through this variable we can set the value of another variable to whatever was input by the answer. By the answer that the user inputted. Let's go ahead and test this out. And so we run the code, and you notice we ran through right here. It wants to know the difficulty. If I put in, say, 2 and press enter, and everything stops. No big deal. Let's test it out again, and let's say we got somebody with they didn't quite read the question and they put in a 4, or maybe they pressed the wrong key. Press enter. Let's keep asking. 5, 6. Let's try 11. Enter. 22. Okay, 0, 3. All right. Well, 0, 3 worked because 0 is actually not recognized as a value when you put in whole numbers, but that's not important. Okay, and just for the record, I didn't know to do that. Anyhow, if they put in letters right here and click on enter, it's still going to keep repeating, and you can see right here it puts the difficulty value to whatever you type in. Also with these as well, you can click on the check mark box if you need to, and that will input the information into the difficulty variable as well. Okay, so you got a good idea on what's going on with this portion of the program. Okay, underneath the difficulty, we're going to do some further calculations, or maybe not so much calculations, but we're going to make some decisions based upon what they put. We're going to use these if-else blocks. We're going to put 2 of them right here. I'm going to right-click and duplicate it, and this is called nesting. We're going to take the second if-else block and put it inside the else section of this right here, and we want to say if difficulty is set to a certain value, we want to set the range of random numbers to be a particular value, and the same holds true if we were to go for the medium or hard difficulties. I'm gonna go ahead and right click up here on this equals because I know when to use that, and I'm gonna say if they chose difficulty 1, we're going to set the high range and the low range to a particular value. Now over here we don't have those variables yet, so we need to make those. So let's go ahead and create that. High range, low range. Okay, and let's get 2 of these. It doesn't matter which one's on top or not. And I'll put them right inside there. Okay, so if difficulty is 1, we'll make the high range a particular value. Let's make that 10. In low range, we're going to set that to 1. Okay, next for the next condition down here, I guess I should explain this real quick. So once we go through this code, they enter in the information, they put a correct input. The repeat until block will stop because we met one of these conditions. It was 1, 2, or 3. And now it's going to come down to these if-else blocks right here. And here's where we're going to set the values. And if difficulty was set to 1, it's going to set these variables to these values. Right here, this is nested. So if they did not put 1, we'll move to the else section of this block and perform whatever code's inside here. And just by chance, it happens to be another if-else block. And here we'll check another condition. I'm going to right-click on this equal symbol, duplicate, put it right there, and we're going to change that to 2. And I'm going to go ahead to the top, set high range, right-click, duplicate, it copies both of those, and I can put them right there. So if they chose a medium difficulty, we're going to set that range to say 100. And let's leave the low range at 1. So it goes, you know, from 1 to 100. So if they choose 2, it goes to that value. And let's say they don't choose 1, they don't choose 2, then by default they come down here to the last else section, which will be 3. We don't have to state it because that's just the order of operations there. And let's go ahead and duplicate this and put it right there. And for our high range, let's leave that at 100. But for our low range, let's have some fun here and test it out by making the low range go to a negative 100. So if they choose a difficulty of 3, they can have a value going from negative 100 to a positive 100. Now that we have it all set up, let's go ahead and test this out. And you can see high range and low range are over here. So let's look at the values. We'll click on the green flag. We're going to choose 1 for easy. Press enter. And our high range is 10 and your low range is 1. Let's run it again. Let's choose 2. And our high range is 100 and our low range is 1. Make sure all of this is being set up as it should be. We should have had the difficulty reflect whatever you type in. Score should be set to score is set to Y. Wow. How did I do that? We want score to be 0. Okay, we don't get Y's for scores around here. Okay, and last but not least, put in 3, enter, and then your high range is 100 and your low range is negative 100. All right, everything seems to be looking pretty good with this script. Let's go back over here to our manager script and we're going to finish programming this. And you'll notice sometimes I use the terms block of code or script. Okay, those terms are interchangeable with one another. I'm sure somebody out there has a strong opinion on which one you should use, when and where and why and what and how, but just for the record, you know, as long as you know that I'm talking about the same thing, you can worry about all the huge details as you move further along in your career of programming. For right now, just understand a script and a block of code in this video pretty much means the same thing. Let's go and start programming our main game manager here. We've got the broadcast tool working. We want to use a repeat until block because we're going to keep repeating the process of the game over and over until a condition is met. And that condition is going to be checking to see if our play again is set to no. That means the user has decided to not play again by entering in a Y for yes, that they want to play again. Oh, I'm sorry, I got that confused. So if they enter in no into play again variable, that will cause the game to start to turn off. And we're going to put in a block called go to front. We didn't have to put this there, however I like adding these, especially when I have a lot of variables and I know that this is my main sprite. Say this was my main character in a video game, I would always want that to be in front of everything almost all the time. So by using these go to front blocks right here, it makes sure that the sprite will be in front of all the other sprites when it layers, and you can see it's right there in front of the sprite. If we didn't have that in front, it might actually appear behind and get hidden, and that could cause some issues for you down the road. Next, we want our data. We want to put the change, and we want to change the round by 1. Okay, notice how I accidentally started my script just by double clicking on it. Actually, I didn't double click, I just slowly clicked twice. That will still cause it to start, no big deal. I want to put a say block right here. We're going to use something called concatenation with a join block. We'll put the join block right there, and we want to join the name or the word round, also known as a string literal, and we want to tell the user what round it is. The cat will announce which round it is by saying round, and then we're going to use the data from the round variable so it'll show up on the screen. Let's go ahead and run it just so you can see what I'm talking about. Let's say 1 for easy, round 1, okay? And then it's going to keep repeating over and over again. If you did the other video, you'll notice this is doing the same exact thing. Just because it's repeat until, it's going to keep going until play again equals n. And we can actually do that right now. Choose play again. We'll set it to capital N, press enter, double click the block, and you'll notice that the script stopped. You can tell it stopped because that yellow halo around it disappeared, and also it's no longer saying round number. Okay, next we want to get a repeat block. This is what's going to control how many times the game plays questions. In our case, we're just going to have it repeat twice, so that way it doesn't take very long as we test everything out. We want to go and get some broadcast blocks. We're going to get the broadcast and wait block. The broadcast and wait blocks, we'll need 3 of these. They send a message out. We already used one right up here with the set difficulty. What happens is it sends a message out to this function, and this function will complete its entire code, and this script right here will not go forward until this is done. And you can see this in action whenever we run the code. It sets the difficulty, sets all the ranges, and then once that's done, it'll come back over here and start executing the rest of the code. And inside our repeat, we're going to go ahead and put these 3 broadcast blocks, and I believe we'll have to create some new broadcast messages. Our first one, whoa, stop that, silly. Our first one is going to be set variables. I hope I spelled that right. Yes. I would make my 3rd grade teacher proud of me. Next, we want to randomize variables. Whoa. Click on OK. And then last but not least, we want to create a 3rd message called set answer. Now that you have those 3 complete, we're going to go ahead and create these 3 functions separately. We are going to create the set variables first. We want to get the hat block for the broadcast and choose set variables down there. And we want to come over here to data and get a set block. We're going to get 4 of these. So make sure you have 4, connect them, and then we want to set the player answer. Oh, we don't have that created, so let's go over here and make a variable. We'll type in player answer, and whoa, I put a capital L. We don't want that. So player answer, and I haven't mentioned this yet, but there's 2 options. We create variables for all sprites and for this sprite only. This is a concept known as global variable for all sprites. That means these variables can be accessed by any object or any sprite or even the stage in the program. If you choose for the sprite only, that makes it a local variable, and that means it's only accessible within the sprite itself. Okay. Now, just so you know, there's some exceptions to these rules, so don't worry about the details, but just know overall for all sprites, it's a global variable. It can be used by anything. For the sprite only, it's a local variable. It can only be used by that particular sprite or object. And we want the player answer to be global. We're going to go ahead and set player answer to 0. Next, we want to create another variable here. We're going to call this one output A. Whoops, that's output 1. So we want output A, make another variable called output B, and last but not least, valid entries. Our second block down, we're going to choose output A. Our third one down, we're going to choose output B. Fourth one down, we will choose valid entries. In output A and B, we're going to put in a symbol here, or a letter symbol. Capital N, lowercase a, capital N. That stands for not a number. Okay? And that's going to be a term within Scratch, and it's actually kind of commonplace with any programming. What it's saying is if we have a division scenario where we're trying to divide by 0, that's not possible. So it'll give us an output called not a number. And we set it to not a number to start off with, so that way we don't have any sort of errors in our calculations, and we can force the program to go set the variable to a value that's not 0 for the denominator. Now we also do a safeguard with this by making our ranges here on these different values by starting the low range at 1 and going up to 10. However, this will happen. We could get a 0 when we have our low range going to negative 100, because 0 is within the range of negative 100 and positive 100. So this will come in handy for that. And down for valid entries, we're going to type in the word false, because we want to make sure that it's set up that there is no valid entry yet. And once we do get a valid entry, we'll set that to true. And let's see, I think that's everything we need for that particular function. I'm just going to drag it off over here to the side, just kind of put it right there underneath the shade of this script. And next we're going to work on randomized variables. Now we are going to make the randomized variables function. We're going to go through this one kind of quick here. So we want a randomized variable message name inside the broadcast receiving hat block right here. We're going to go over to our data section. We're going to get the set block, and we will need, let's start off with 2 of these, and we'll put them right there. We're going to say numerator A. Whoa, we didn't make that. See, I told you I'd forget. So we want to make a variable called numerator A, and that's going to be the numerator for the A choice, which will be on this side over here. And then let's go ahead and make another one, numerator B. Okay, so go ahead and set numerator A to the top one and numerator B to the bottom one. It really doesn't matter. What's important is that you know which one is which. For right now, keep it exactly like mine so you don't get lost or confused. Okay, we want to get these pick random number blocks. These are going to allow you to generate random numbers. And we want to have a range. It's automatically inputted range, and we could do something called hard coding. That means when we type in the value like that. Okay, but we don't want to do that. We want to base it upon a variable that we automatically generate from our code over here with the set difficulty. So we want to get the high range, and we're going to put that on the right hand side of the block, and we're going to get the low range. And you know, I could have just done this. Let me delete this block, and I could just right click and choose duplicate. Now I have 2 good copies of each other. I'm going to go ahead and stick it right there. So when we randomize the variables for numerator A and B, we're going to put these range values in for this random number generation. Next, we want to use a repeat until block, and we're going to get kind of fancy right here. I'll move my block over so I can see a little bit better here on the camera. We want to get a AND operator. We're going to stick it inside of it like so, and then we want to get 2 not blocks. We'll put one right there. I'll tell you what all this code's saying here in a second. And we want to get 2 equal blocks. We're going to put those inside of the not. Okay, if you can see, that's pretty complex. I'm going to drag it out so you can break it apart, just so you can see in a little bit more detail. Okay, and I'll build it outside of the entire function. Actually, I'm going to reverse build it this time. I'm going to put my equal symbol inside the not block, this other equal symbol inside that one, then put it inside the left hand side of the and this one in the right hand side of the and. Okay, so we have that happy little block right there, and we're going to come over here to data, and we want to choose the variable that we're creating right now called denominator. Whoa, I misspelled that, didn't I? Denominator A, and we also want another one called, guess what? Denominator B. Okay. And we want to get denominator A, put on the left-hand side of the equal symbol, and denominator B on the left-hand side of the equal. And we're going to hard code, which means we're going to type into this entry block or an entry section inside that equal symbol, and we'll put 0 inside both those. So what we're saying is, we're going to put it right there. We're going to repeat the code in here over and over again until denominator A and B are not equal to 0. Okay, let me repeat that one more time. We're going to repeat all the code inside here over and over and over again till it's time to go home, until denominator A and denominator B do not equal 0. Did you catch that? So denominator A equals 1 and denominator B equals 0. This code will keep repeating. If denominator A equals 10 and denominator B equals 11, the condition will be satisfied and our code will stop repeating and it'll move on to the next section. Okay, we're doing that so we don't get a 0 in the denominator. Next, we want to get 2 more set blocks, and we want denominator A on top, so we just kind of keep a normal strategy here. I'm going to place those inside, and I'm going to duplicate this pick random since it's already made for me. I'm going to get another one from that one. Scratch is pretty nice. You can just kind of copy and paste those areas out there real quick. It's kind of nice, but other times it's kind of a pain too. So that way our denominator A and denominator B will have a random number generated from the low range to the high range. Pretty cool, isn't it? Next, we want to set our output A and output B to values that are generated by the random numbers. And we want to do some division here because we want to find out what the value of numerator A divided by numerator B, whoa, hold on. We want to know what the actual value of the fraction is for numerator A divided by denominator A. And the same holds true for numerator B and denominator B. That is a mouthful. Y'all should try making your own video with this, and you'll see what I'm talking about. So we want numerator A divided by denominator B. Whoops. You see that? It kicked it out. So you have to keep your eye on Scratch. It'll make errors. If you're not paying attention, it'll trick you sometimes. Okay? And you just put that right there. And I'm going to show you a quick way to do this. Right click on the division symbol, choose duplicate, stick it right inside there. Right click on the variable name, choose numerator B, then choose denominator B. Where'd you go? It's in here somewhere. I know I created it. I bet you I know why. My screen's not low enough. So, oh, it's already on denominator B. Oh, this one should be denominator A. There we go. That's why it wasn't working. I was wrong. Okay, so numerator A, denominator A, numerator B, denominator B. Okay, this will produce your random numbers for your numerators and denominators. Make sure it's not 0 with this piece of code right here. And then it's going to divide the values to give you a number for your output A and output B. And we're going to use this to determine what is the correct answer in the next step. Next, here on our broadcast messages, we see that we want to create the set answer function. I'm going to drag this randomized variables off to the side. And if you're new to Scratch, you may not know this, but you can drag your blocks and lay them on top of each other. It makes things kind of messy, but you might get in a situation where you might have to do that. However, be careful when you drag these on top of each other. You could get in a weird scenario where something tries to connect to each other. I've seen it do it in weird times and places, so just keep your eye on Scratch when you do those things, and don't get into a bad habit of start laying the scripts on top of each other. Okay, the set answer. This is a quick one. We shouldn't take very long making this one. Get your hat block for receiving the broadcast message. Choose set answer. We want to get 2 if-else blocks right here. We're going to nest the second if-else in the first one down here in the else section. And we want to get a greater than, Boolean operational block here. And we want to see if output A is greater than output B. And remember, these calculations were coming from over here. Whoa, I meant over here with the randomized variables when we made that calculation right there. Okay. Where was I going? Oh, yes. So we want to set our correct answer, which I need to make that variable. We want to set the correct answer. Well, hold on. Create the variable called correct answer. Then we want to set the correct answer. And we want to make that A. We're going to duplicate this, put it right in here, make it B, right click, duplicate, and set the bottom one to C. For it to be B, okay, we're going to have to check a condition, and we need to see if output B is larger than output A. Make sure you have the correct outputs on here. A is larger than B, so the correct answer is A. If B is larger than A, then the correct answer is B. By default, if either one of these is false, or if both of these are false, then the correct answer is C, which means they are equal to each other. We don't have to put a condition in here to check to see if they're equal, because if it's greater than, if you can see that if A is greater than B, or excuse me, if A is not greater than B and B is not greater than A, therefore the correct answer would be C, that they are equal to each other. And that is the set answer block. I just paused the video and made a few changes. Actually, I made a whole lot of changes that I didn't capture here on the video, but I'm going to walk you through the completed sections of the code. First thing that I completed was this block of code, which was our green flag block right here. So some things I added, as you can see, I added a say block because we're going to ask the user which fraction is larger, A, B, or are they equal? And then we put a wait until block right below that, so it's going to cause the code to actually stop and wait for the user to, choose a selection of which one's correct. So they'd click on the A, the equal symbol, or the B. And then this is going to keep waiting until the player answer does not equal 0 anymore. And we set player answer to 0 over here when we set this block of code up underneath set variables. So it's just going to keep waiting until they click on one of these choices, and A, B, or the equal symbol will allow it to do so, because it'll set the answer or play answer variable to something else. Right here we choose the change score broadcast. We send that out because we're going to write a block of code based upon that. And then underneath the repeat, we have another broadcast message called play again message, and this block will send a message out telling the game that we want to check to see if the user will play it again or not. So let's check out the change score block. I hid these down here. I'm going to go ahead and drag it up. We'll do one at a time. So we're right down here on the change score. You might want to pause the video and go ahead and create this. There's nothing really new or different that I've done with this piece of code. I think all the variables have already been created. So when we receive this message, we're going to check to see if player answer is equal to correct answer. And if that's true, those two are equal, then we're going to change the score by a +1, play the cheer sound, and say you are correct for 2 seconds. If this is false, then it's going to come down to the else section, and here we subtract 1 from the score, play the boing sound, because everybody loves that, and then we're going to tell them that you're wrong. Inside these data or text entry blocks, or little boxes right here inside the say blocks, you can type in whatever you want. So if you want to change something different, you're more than welcome to. The sounds, where did I get the sounds? Up here on the sounds tab, I was able to import these from the Scratch library, and you can get to that by clicking on the little kind of audio speaker looking signal, and that'll bring up a tremendous amount of different audio signals or audio files. And you can also come over here and mess around with the different sounds and change the effects. Just go ahead and experiment with this stuff when you get some time. Let's go back to our scripts. Let's look at the play again message. Okay, so change score, we add points or deduct points based upon if they get it right or wrong, and then we'll broadcast the message to see if we're going to play again. And let's go ahead and drag that up. I'll put this one over here on the side. So play again. We have the variable set to a question mark just because we need a placeholder. We could have left it blank, or we could put 0. We could put something in there. But instead I put a question mark because, well, it's a question. Do we want to play again? Yes or no? So when the message gets received by this block, we're going to see if play again is equal to capital N for no, or if it's equal to capital Y for yes. Okay, and we're going to keep repeating this little section right here until it's capital N or capital Y. And we're going to ask them while it's repeating, do you want to play again? So answer yes, Y for yes, or N for no. And we're going to set the play again variable to the answer that they input into this little blue block right here. So if I click on this, you can see we get the little blue block right here, rectangle, that allows you to type in whatever you want. Okay. Let's stop that. So once the variable is set from the answer from the player entering this in, this will determine if we move forward or not. And we can determine that because at the very beginning we set this repeat until block right here. We said if play again is equal to N, okay, or let's rephrase that. We're going to keep repeating everything inside here until play again equals N. So when play again equals Y, because they put Y right here, and when they put Y in, it's going to stop that block of code. Then it's going to come down here to the say block. And here we use some of our fancy concatenation, and we use the join block, and we concatenate it with the score variable where we will tell them what their score is. Clear as mud, right? Okay, let's look at the rest of the code for the other sprites. These are a lot more simple than this one. So let's come to Sprite 2. Sprite 2, due to layering, I want this little blue background with the black rectangle that makes it look like a fraction. I want that behind everything. Okay, and I do that by setting it back 10 layers. And you know what? One other thing, if you have a scenario where you have tons of variable information all over your screen, I'll show you how to go through and correct all that here in a second. So if you have things on your screen, such as all the variables, you know, there's all this stuff all over the screen, or it doesn't look the same as mine or whatever. Okay, we'll go through and clear all that up here in a second. I'm going to go ahead and remove that because I don't need it. Oh, I kept difficulty, didn't I? I didn't need output A and output B. There we go. Okay, so back to this one. So we're going to send it back 10 layers. That ensures that it goes behind everything. And here we put in these XY coordinates. The coordinates aren't so important if you're a couple digits off, no big deal. This is -169 and positive 15 on the Y. And again, we're always sending it back 10 layers just due to Scratch. It's a little bit weird sometimes. We want to make sure that these blue backgrounds are always behind. See what happens if I accidentally click on it? But if I'm running my program, it automatically snaps behind. And if your user drags it off to the side, it's automatically going to go back and immediately appear behind everything. And just a little bit of trivia for you. These variable boxes, the variable output, appear on top of everything. You cannot layer the variable boxes. Okay, so you got the information. Next, Sprite 3, which goes behind B, does the same exact thing. So you might want to pause it and write down those values. The button 2, I'll just jump over here to this one. I called it button 2. I probably should have called it something more consistent with the other ones, but here we are. Anyhow, this does the same exact thing. So again, click on the green flag tool. You'll notice that these backgrounds don't move. Okay, just make sure your game runs smoothly every time. Okay, the A block here. Whenever the user clicks on the letter, the sprites right here, the letter A, we're going to set the player answer to the letter A. Okay, when they click on the sprite, it only happens when you run the game. If I choose my player answer, which is right there, okay, you know it's set to C. If I click on this, it'll change it to A like so. Okay, so that's what happens with that. Now we're able to change the color with this repeat until block. We're going to say keep repeating this code until play again is equal to N, which is real similar to what we had over here on CalcuCat, where we were checking to see if play again is equal to N. Okay, so if play again equals to N, we're going to stop this piece of code. If not, we're just going to keep running it over and over again. So no matter what's going on with the program, I'll click on the wrong button, your letter is always going to light up. And the same thing with the B. Now what happens on this code is that we're telling it to go to a specific XY coordinate, then we're telling it to go to the front, and then we're saying if it's touching the mouse pointer, if that's true, we're going to check inside of here to see if something else is happening. We're going to check to see if it's still touching the mouse pointer and the mouse is down. This is a little bit of a double kind of check here, maybe a little bit too much checking, but I found with Scratch, sometimes it's better to check more often than not. We could have put all this up in the first line of code, but I like to check it again because sometimes Scratch is a little bit slow and the users are faster than what Scratch can process. Okay, not all the time, but I guess I've been messing with Scratch since 2009, 2010, and I've kind of maybe developed some Scratch habits that aren't so modern. Okay, but nonetheless, so if the mouse pointer and the mouse down is true, we're going to change the costume to the A block 3 costume, which is the green one right here. And you can see that the first one is orange, the second one is yellow. Okay, so if this is true, okay, mouse pointer's down and it's touching it, we're going to change it to the green one. If it's not true, which means that the mouse pointer is touching it, but the mouse pointer is touching it and is not down, so if that's false, we're going to come to this costume, which is going to be the A block 2, and that's going to be the yellow one right there. And last but not least, if we're not touching the mouse pointer right here on this code, which means this nested if-else section doesn't even happen at all, it's going to default down here to this else section, and we're going to go to the A block, which will be the orange. You can see that right here while we run it. So if my mouse goes over it, you notice it turns yellow, which is the A block 2. So if you look at my code, A block 2 is happening. And then if I click down, it turns green. Okay, see it's turning green. I'm holding my mouse button down and it makes it turn green. That means A block 3 is happening. And if my mouse is not touching it at all, then A block, this one right down here, is what's taking place. The B block, it does the same exact thing. The only difference is it has different XY coordinates, different costumes. Make sure you switch those costumes out, and it sets the player answer to B. Okay, so pause the video, make sure you make those changes for the B block. And the equal block is the same exact as the A and B. The only difference, we set the player answer to C, different XY coordinates, and we changed it to different costumes. And here's an error. Check this out. I noticed that earlier it wasn't doing what I wanted to do. Okay, I didn't change the costumes. It should be B button 3A, B button 3A2, and B button 3A3. Okay, so I made a little mistake. Let's change it. All right, should be A3, A2, and A. Okay, and what happened was I had copied the B block over to the equal block, and I forgot to change those costumes. Okay, and since the costumes were different than what was inside the equal block's costumes, it didn't change them out. And when we run the code, we should be able to see that we have the equal block always goes to those XY coordinates no matter where we drag it. Hey, did you see that showing up down there? That's kind of weird. Oh, look at that. That's kind of cool. Okay, and same thing with the B. No matter where we move it, it should show up around there. I believe that is the end of the program. If you run it, it will work. I've already tested this out, so just check it out, make sure it's working. One for easy, then round 1, you might want to go through and make sure that you're getting points subtracted for wrong answers and points added for correct answers. Did you hear everybody cheering me on? That makes me feel good about myself. Okay, variables. Okay, what in the world did I do with all these variables right here? How do you get yours the same? Yours probably looks something like this. Okay, so this is numerator A, and I know that because I set it up. I'm going to turn it to its normal readout. Right click on this one, normal readout, right click, normal readout, right click, normal readout. Okay, so make sure you have all the same variables on your screen that I have in mind. And if you don't, you need to add some, just click on the check box and see if it shows up or not. And if you have one that looks like this, where it's the large readout screen, you can't tell what it is, just right click and choose normal readout, and it'll tell you the variable name with its value. So I'm going to go ahead and have over the letter A, numerator A, I'm going to turn it to large readout, and denominator A, change that to large readout. So those are both on there. And then I'm going to do the same thing with the B, make it large readout for numerator and denominator. And you can move these around and make them look a little bit nicer. If you want to do a different layout for yours, you're more than welcome to do that as well. Player answer, you might want to remove that. You can remove it by coming over here and selecting player answer, or you can right click and choose hide. In some cases you might have a scenario where you accidentally choose slider. Slider allows you to use this little tool right here to change the answers based upon a slider of 0 to 100. You can also change those values by using some formulas. We're not going to worry about that for right now because that's kind of not what we want to do. So I'm going to get rid of my player answer, and I believe that's it. So test your program out, make sure everything's working. You might want to double check any code over here. I'll set up on the screen so you can pause it and check it out. Just make sure you got the majority of all the code. I don't think there's anything else out there. Okay. All right, so thanks for watching. Make sure you subscribe and make sure you hit the like button. I hope you liked it. Okay, I hope you learned something. Just keep programming, keep practicing with this. It's all going to lead to bigger and better things. Once you get really good at Scratch, you can move on to Java and start using maybe some game engines like Unity. I have some other videos out there you can check out. So keep watching, keep programming, and we'll see you later.